Hey everybody, it's Shaban, and let's say you want to get into programming, or maybe you are a programmer and you're considering game programming because you think maybe game programming will be more fun than other forms of programming. Well, it might be nice to know, well, how is game programming different than other forms of programming? And that's why today we're going to be talking about the 5 ways that game programming is different than other types of programming. And today we're going to start with number 1, which is performance. And this one's pretty quick and easy to understand, so we'll get this one out of the way. So when I say performance, I'm talking about how quickly does the game run. This is entirely critical when it comes to games. When we're talking about, web applications or, phone applications or that kind of thing, it can be annoying when an application is kind of slowing down a bit, or, the website takes another couple seconds to load than the user wanted. But when we're talking about games, we're talking about milliseconds mattering, okay? In fact, a lot of games aren't even allowed to be shipped or published onto a marketplace such as a Nintendo marketplace or Xbox or PlayStation marketplaces unless it meets those performance thresholds where the game is running, however many frames every second. And if it doesn't meet those, then it gets kicked back and it doesn't get licensed. It doesn't get allowed to be on those types of marketplaces. So performance is really important. And when we're in the game programming kind of work environment, optimization and making sure that the code runs to a performance threshold is talked about a lot. Okay, and I want to actually add to this performance because it's also precision that's important. And I don't mean precision like a demolition software where you're like, measuring how long it'll take for like the exact physics of like a building's demolition or, like rocket launch kind of stuff. I'm not talking about mathematical precision. I'm talking about input precision, really, that in game programming, when the user performs some kind of input, whether it's trying to click on a target that's moving quickly, whether it's another enemy or some other kind of target, or whether the player's trying to jump from one platform to another platform, that the player, whenever the player puts in some kind of input with their controller, their mouse or keyboard or something like that, that the character or the game behaves exactly how they expect it to behave. And while that does matter to some degree in traditional kinds of applications, it really doesn't matter as much because usually the person can undo, it's not very time sensitive, and there's certainly not a crazy amount of action happening at the same time. So those are a couple of different things to start off with. And the second thing that makes game programming different is the continuity of interaction. Continuity of interaction. Okay, it's not just like interaction, it's just an execution, really. Okay, so when we're talking about traditional forms of programming, I want to start off, let's just kind of draw what that might look like. Okay, so I'm going to kind of drag this up here. Oopsie daisy. Notice how this application is like that input precision. I'm not freaking out and throwing my controller because it didn't behave exactly how I wanted it to. All right, right. So in maybe a normal type of application that you might be creating, you might have a let's just call this front end. Okay, so I'm gonna type front end. You might have heard of that, or maybe not. Oh my gosh, I perfectly did. That was pretty cool. So front end. And so this would be kind of like the web page that the user sees, or maybe it's the screen on the phone and they can see the buttons and all that kind of stuff. So this is what the user sees. And then you might have what, just to keep things simple, right? There's the back end, right? There's the front end and there's the back end. And I'm just going to try to draw another rectangle. Beautiful. All right, so there's the front end and the back end, but then there's other types of, there's other things, right? There's like database. So I know you might say like, well, it's part of the back end. Well, yes and no, right? So what I mean is that, so the front end, like it takes perhaps the user input, and that it would be a separate part of your code altogether, potentially, if you're doing the model view controller type of paradigm. But the point here is that the user interacts with the front end, and then the commands are perhaps handled on the back end, on a server, And then there's databases involved. There might be even other parts of this application stack, so to speak, involved. And then the database is where the backend is retrieving the information. So the state of the user's data is stored in a database or in a file or something like that. And then the backend, performing all the kind of logic and all that kind of stuff, grabs that information from the database. So it kind of comes in here, makes that request. And then the front end, the user makes a particular request, and that goes to the back end. The back end grabs the data from the database, and then that information is served back to the user in the front end. And this kind of process is very common in most type of application development. However, the flow of execution is often just really kind of staggered, right? So on the front end, the user will make a request, right? It'll just be this kind of static page that's loaded, or a view of the application like Microsoft Excel or something like that, where the graphics are just kind of just being rendered in this idle state. And then the user interacts with that front end, and then it sends some kind of request, add something to cart on a web page or something like that. And then that request is then processed, behind the scenes in this kind of black box that the user doesn't know about. And then it goes boop, and it sends back some kind of result to the user, and the state of the application goes back to this idle, waiting for a user to make some kind of request. And the user doesn't have to be an end user. It could be, some kind of user of a system internally for maintaining documentation or something like that, right? There's application development all over the place. But in all these different cases, the continuity of interaction is just staggered, where it's just send a request, receive a request. But when we're talking about game development, we introduced this concept of what is called the game loop. Okay, so there's the game loop. Okay, and this isn't talking about game design like core loops or anything like that. Game loop is where the game state is continuously being updated every tick, so often every 60th of a second, right? And so it goes through this loop that would typically be called the game loop, where let's say that the game is, the game is waiting for player input, right? So there's player input. And I'll just kind of draw a box around it because we like our boxes. Beautiful box. We're going to go with that box. And then we've got the update. So I'm just going to call it update because a lot of different game engines like to call it update. It might be called, something else depending on the game engine. But the update is where the game is updated, where the state of the game is being updated, perhaps. But there are other parts of this game loop, such as rendering. I'm going to say let's say rendering or something like that, right? And so we've got rendering, where the graphics are rendered in the game. And so what happens is that the game is waiting continuously, kind of like a normal application, but not just in this idle state. It's waiting for the player input. And sometimes there's input, sometimes there's not. But whether or not there's input, the game is continuously updated, because if there are enemies in the game, they're kind of moving around, or other NPCs are moving around, or maybe the sky is changing, or all the different states of the game are updating in real time every fraction of a second, okay? And then it comes back up to the top and comes back down, and the next cycle of the game loop occurs. So it's kind of like an infinite loop, one of those while loops, like while true. And that's really a pretty accurate way to put it. It's like an infinite loop that starts when the game begins, that gets updated every 60th of a second. And that continuity is maybe not entirely unique to game development, but just the number of different things that are involved that are being updated every second is something that is pretty unique to game development. So continuity of interaction and execution is important, but I want to add to that, and that's number 3, which is the order of execution is critical, okay? So order of execution is entirely critical in game programming. And so what I mean by order of execution is that when I say that the player input happens and then the update of the game happens and the rendering happens and all that kind of stuff, it happens in that order. And the programmer relies on it happening in that order, right? So it might be there's rendering, and then maybe there is audio, and maybe in addition to rendering, there might be something like animation or something like that. And maybe even before there's player input, there might be, like initialization, right? So there are different object initialization for those people in England. I'm spelling it with a Z. Sorry. Or I guess not just England. All right, initialization. Why did I just put that over there? Like whoop, whoop, whoop. Comes down here, then goes into player input. So initialization might happen first, right? Because there's objects and enemies and player, elements that every single frame, something new might be created, and that object that might be created gets created before the game recognizes or looks for player input, or maybe it's the other way around. It kind of depends, right, on potentially the game engine we're talking about or the software that you're using to develop your games. But then after the player input is received, and then it goes into the update, then it goes into the running. And the reason for why this is important is because if the player produces some kind of input and that happened after the update, then there's a frame delay, and that frame might be like a half frame delay with something else has happened that has killed the player, and the player felt like they should have been able to avoid it because they pressed their button first. So you want to make sure that you're registering input first, but that's not the only example, right? There's also stuff like physics, right? So physics, where does physics happen, right? So where are you checking to see if an object is colliding with another object? And so physics isn't something that's necessarily exactly congruent with everything else, but it's important to consider, because if the physics isn't happening in the order that is expected, then the player might fall through the ground, or you might be able to walk through a wall or something like that, or you try to perform an action and it didn't quite happen the way that the player expected. And the programmer needs to be fully cognizant of the order in which these things are happening, or else if they all happen in a random order, then the game is going to possess random behavior. So it's very important that it all happens in the correct order. When we're talking about other types of applications, the order of execution just does not matter very much at all, right? So you've got like a little JavaScript applet showing some kind of like diagram on the web page. Maybe a little sound happens. It doesn't really matter like if the JavaScript thing starts rendering before like another element of the web page starts rendering. They're all kind of islands in their own different way, and it doesn't really matter that much. Now, of course, order matters in the sense that like you don't want to like let someone accidentally buy something for the wrong price, but those types of things are much more easily avoided than the like millisecond difference between each frame in game programming. So order of execution is really, really important. Cool. So the next part that I want to talk about, number 4, is that the different parts of the code it's a lot harder to decouple. So different domains interact more intimately, let's say. Different domains interact more intimately. It's harder to avoid. So what I mean by that is that each of the different elements of a traditional, application stack in other types of application development it's easier to kind of sequester off the different elements into different places in different departments, where each part is kind of like a black box. So the front end, the user interface developers, the programmers, the JavaScript people, CSS, all these kinds of people who are writing the code for what the user sees. What they do is they have this information that they receive from this black box, right? They receive information in some kind of package like JSON or some other kind of thing. They receive this information, and they don't care how that information got to them. They just care that that they have the data that they can then present to the user. And the way that that information is presented to the user, like how, the structure of the web page and all that kind of stuff, the server doesn't care about that whatsoever and doesn't need to know that, right? So there's like no real visibility. I'll draw like an eye here, like a little icon, right? No visibility between front and back end. They don't know what each other are doing. All they need to know is that the back end's like, oh, I received a request. And the request is in form of some kind of little package of information, a package of data from like a form. And then it's like, okay, I received something, and then I'll give something back, right? So the whole like ideal of programming where everything is put into these little modular black boxes, black box meaning like you can't see in them, they're not transparent. You just know that data in, data out, right? And every part can be kind of constructed in that way. And it's not too difficult to be able to construct something in that way. In game programming, it is harder to decouple those systems. Okay, while that's still the goal, that we can have each element of the code not depend too heavily on another element of the code, because then you get this spaghetti mess of dependencies where you can't modify one tiny bit of code without having to know and understand all of the other elements of the code, right? You don't want the front end application developer to have to understand exactly how the database is structured in order to be able to, create a beautiful looking web page or an application on a phone. But when we're talking about game programming, it's a little bit harder to avoid, because let's say we're talking about a game where, a player character lands on an edge, right? So you have to understand the location of the player to know whether or not the player has reached the edge, and so you have to detect if there's collision and whether the edge of the let's just kind of draw that, because why not? The character is like, wee, landing on the edge, hooray! And when that occurs, first you have to determine that it occurred, right? And once that has occurred, then maybe there's an animation that plays, right? So there's kind of like a little, I don't know, animation of the player character landing, right? Or maybe, and then there's like a particle system where there's like a little ploof of dust that happens. So there's the animation of the player, but then there's this dust animation. So is now dust related to player? Do we have to worry about how the player works in order to make sure that the dust works correctly? And then there's also maybe this little like audio clip. This is supposed to be a speaker. An audio clip that occurs when the player lands. It plays like, hey, I landed on the floor. So, oh my goodness, a bunch of things happen all at the same time, right? The audio needs to know that the player landed. The dust needs to know to appear when the player landed. Maybe you landed on a platform, and now the score system needs to give you points because you landed on this platform correctly or in the correct way. And maybe the other players, it's like a multiplayer game, need to know that the player has landed and update the screen. So now you've got all of these different systems that have to, in some which way, know that this moment in the game has occurred. And how do you do that with keeping things modular and decoupled? That's part of the challenge of game programming, and where you can quickly die by 1,000 paper cuts, so to speak, by putting in like little hacks here and there, and it just kind of you break down and your code becomes impossible to manage. So that's just another example, and it's still doable, but it's a lot harder. And so if you're going to be getting into game programming, to make sure that your code architecture supports being able to add another type of animation without touching what happens with the player and all that kind of stuff. Okay, and then the last difference between game programming and other forms of programming, I'd say, is that just the development process itself. The development cycle is shorter. So the dev cycle is shorter. It's more crunched because there are time limits. And lastly, I would say no. Let's say it's not open-ended. Let's say that. And then finally, it's doesn't get merged with other software. So to explain what I mean by this, the dev cycle is shorter. So that means that when you're planning a game, you know that there's a point where you finished the game. And so a lot of these programmers, they're just not needed on that particular project anymore because the game is done, right? You've made the game, you've shipped it to its marketplace, and now you're just kind of maintaining the game and fixing bugs and that kind of stuff. And that isn't to say that all games are like that, but by and large, that's generally how games work. And you say that you need the game to be released within a particular timeline, and once it's out, it's done, right? That's not the case with software as much, right? So if you're creating Photoshop, you're going to be maintaining Photoshop, and you're going to be creating this Photoshop forever, right? Ideally, or whatever it might be. So the dev cycle is also shorter, because in order for you to be able to release a game and make sure that like it's going to be profitable, you typically are doing like this sprint where you get something playable out there, depending on, like, again, what type of target hardware you're looking at. So for a phone, development cycle is even shorter than, say, for like the PlayStation or something like that. But when the game goes from zero to entirely polished and finished in a shorter period of time than other software, where it's like you just get it to a certain point and then you can add features and so on and charge them for those additional features. It's more crunched because release dates are really, really important in games, right? You say that this game is coming out in November 20, 20X or whatever it is. You're going to hold to that release date. Generally speaking, with other types of software, you're not saying like, that, okay, everyone's been waiting for this release date, and so we got to make sure that we make it on time. Rather, just certain features get scrapped and they move to the next version or something like that. With games, you can't just say like, oh, we're just gonna move the boss fight to like a different version of the game. No, the boss fight's got to be in there, and it's got to be done and ready and amazing, right from the beginning. It can't just be something you push off to a different update or something like that. So the crunch is real with game programming, and so that means that even if you're trying to avoid the crunch culture as much as possible, there is still that pressure. The pressure is on once you're especially getting to the ends of these development cycles, because you're running out of funding and you still have to have everything in place, and so it can be a little bit higher pressure. And it would be irresponsible to not mention that. And it's also the development cycle is not open-ended. So when I say that it's shorter, but it also doesn't go on forever, right? Unless we're talking like World of Warcraft or something like that. Generally speaking, these game development cycles don't just like stay open forever. There are like downloadable content, DLC packages that are being placed, but people are moved to different teams as they work on other projects, and they don't kind of sit on one project forever. And then finally, the software doesn't get merged with other software typically, right? So, and that's actually a good thing, right? So I'm making the other part of stuff sound like really kind of high pressure and scary. But one of the nice things, one of the perks about game programming is that with other software, like let's say some kind of video editing tool or something else, oftentimes companies will buy some other tool, right? They'll buy some other tool, or maybe a data company will buy another company relying on data. And now, oh my gosh, it's now part of the developer's job to be able to take the data from the other source and then bring it into this particular tool, right? So that means like being able to essentially make sense of some other application's database and then bring it into your database. And that's from the database side. But there's also the other elements, right? So like front end. Maybe the front end application for some kind of like video editor is more performant in this tool that was purchased from your company. And now they're like, okay, well, now you got to kind of like find a way to be able to use some of those types of interfaces that are in this other tool, or modules that are in this other tool, and bring them over to your tool. And that means, oh my gosh, now you have to make sense of a totally separate application and be able to reuse a lot of that same code. And that kind of clash can be nightmarish. And game development, you generally don't worry about that problem. You're not like, we bought this other company, now we're gonna like merge this platformer game with this platformer game, and they're going to be the same. No, they'll just make a totally separate game with the same characters or something like that. They don't just merge those two different softwares together, which happens more often in traditional application development. And let's do a bonus one, okay? Bonus. Which is that the languages and tools are different a little bit. Okay, and now you could say that about everything, right? Like when we're talking about applications, whether you're developing a web application or a phone application, or like some kind of, doesn't have a GUI, some kind of like tool for internal use type of application, GUI as in graphical user interface. I'm sure, but game programming has its own kind of domain set of tools and languages. So in game programming, you're going to see a lot more C++, then you'll find C++ in most other areas, right? So you'll see a lot of JavaScript, you'll see a lot of Python in most of these other kinds of programming fields, whether it's machine learning or web development or whatever it might be. But in game programming, there's really not that much Python or JavaScript. It's a lot more kind of object-oriented languages. Not to say that JavaScript, not really. Python can be object-oriented, but I'm talking about ones that are much more class-based, object-oriented, and that's how they're built, such as C#, C++. Those types of languages are very prevalent in game development, more so than maybe most of the other popular types of software development. And that's one type of difference, but there's also the tools themselves. The tools are a lot more demanding when we're talking about game programming. So game programmers often have to have more expensive setups because the tools that they're working with and to be able to test the code and all that kind of stuff in these kinds of games depend on running a game that, again, is performance dependent and so on. Unlike other kinds of application development where you're just working with like maybe a very simple editor where there's no like kind of scene editor where you're dealing with all sorts of highly advanced graphics being rendered in a scene. Okay, well, that's all I got. So that's how game programming is different than other forms of programming. Hope you got something out of it, and I'll catch you in the next video.